Lesson 3, simplifying expressions using the product property of exponents. First off, we need to know some vocabulary words. The base of a power. The base of a power is just the number used as a factor. So what are you going to be multiplying by itself each time? That's the base. So if you look in the picture here, 2 is the base. That's going to be our factor. We're going to be multiplying the 2 however many times. How many times are we supposed to multiply that by? That's what the exponent tells you. So the exponent is the natural number telling how many times the base is used as a factor. So if we think of 2 to the 6th power, 2 is used as a factor 6 times. So 2 times 2 times 2 times 2 times 2 times 2 gives you a total of 64. So 2 to the 6th power is 64. So if they ask you to use the power, that's not the value. The value is what is the overall answer. So the power, you write it with the base and the exponent. So you can use power and exponent the same, they mean the same thing. So you use that, tells you how many times you use the base as a factor. So let's look at some examples here. 7 to the 3rd power. So 7 to the 3rd power means we are going to take 7 and use it as a factor 3 times. So 7 times 7 times 7. So 7 to the 3rd power would be 343. Letter B, half. Since that's in parentheses and the exponent is on the out, when we work with fractions, you have to use the base half as a factor twice. So half times half will give you 1/4. Letter C, 6 to the 4th. This means take 6 times 6 times 6 times 6. And when you use 6 as the base or as a factor 4 times, that gives you an answer of 1,296. 10 to the 3rd. Base 10s are good because the exponent tells you how many zeros you have in your answer. So I'm going to be multiplying 10 3 times. So 10 times 10 times 10 is 1,000. And then we have one with decimals. So that would be 1.4 times 1.4. And when you multiply those, 1.4 times 1.4, you get an answer of 1.96. So there's a couple examples of simplifying expression with exponents. Next example, product property of exponents. The property says when you multiply expressions with the same base, you add the exponents. So the base stays the same. As long as they're the same, you just add the exponents. So on letter B here, it says x to the 5th times x to the 7th times x to the 2nd. You just add the exponents, so that gives you x to the 14th. 5 plus 7 is 12, plus 2 gives you 14. C, the base stays the same, that's w. I add the exponents because I'm multiplying the bases. So 3 plus 5 is 8. 8 plus 4 is 12. So w to the 12th. And then the other one, not all of the bases are the same. So I need a y and I need a z in my answer. So I multiply my y's and add the exponents. So 6 plus 5 is 11, so y to the 11th. And I add all my exponents on the z's. 3 plus 11 is 14. 14 plus 2 is 16. So our answer would be y to the 11th, z to the 16th. Example 3, an application problem. Here in 2006, the fastest supercomputer's performance topped out at about 1 pflops. 1 p-flops is equal to 10 to the third t-flops. Each t-flops is equal to 10 to the 12th flaps. What was the computer's speed in flaps? So we need to convert 1 p-flop to flaps. So I know that 1 p-flop is equal to 10 to the third t-flops. So I'm going to multiply this. I need to get rid of a p-flop. So I have 10 to the third t-flop over 1 p-flop. And the reason why I put the p-flop on the bottom is because I need to get rid of this p-flop. I don't want that label in there. I need to get rid of that. So if I do this, because they're opposite, I'm really dividing them out. They cancel each other out. Now I have t-flops. I need my answer in flaps. So now I have to look at the next part. Each t-flop is equal to 10 to the 12 flaps. I need to get rid of t-flops, so I need to have t-flops on the bottom. And there's 1 t-flop, and that's the same as 10 to the 12th flaps. And that's the label I want in my answer. So now the t-flops cancels this t-flops. I have a label with flaps. Now I just multiply straight across. 1 times 10 to the third times 10 to the 12th flaps will give me my answer. Anything times 1 is itself, so 10 to the third times 10 to the 12th would give me 10 to the 15th flaps. And that's what our answer would be. Let's take a look at another example. If a supercomputer has a top speed of 1 e-flops, which is equal to 10 to the 9th g-flops, and if 1 g-flops is 10 to the 9th flaps, what is the computer's speed in flaps? So we need to go from 1 e-flops to flaps. So I need to get rid of e-flops. And it says 1 e-flops is the same as 10 to the 9th g-flops. So I need e-flops on the bottom. So 1 e-flops is the same as 10 to the 9th g-flops. The g-flops cancel out, or the e-flops cancel out. Now I need to go from g-flops to flaps. And it says if 1 g-flop is 10 to the 9th flaps, so I need flaps on top. That means g-flops is on the bottom because I need to cancel the g-flop out. 1 g-flop is the same as 10 to the 9th flaps. The g-flops labels cancel out. Now I'm left with 1 times 10 to the 9th times 10 to the 9th flaps. Anything times 1 is itself. So 10 to the 9th times 10 to the 9th is 10 to the 18th flaps. And that is our lesson on using simplifying bases and exponents, or using expressions with exponents.